Again, welcome to our first lectures. This is New Jersey City University class named Precalculus. This is a Precalculus class, and this is our first lecture. Our first lecture will cover the set. What is a set? So our objective is the definition of set and also set operations. As we can see here, a set normally consists of an object or a collection of items. So here we say the set is a well-defined collection of objects. There are two ways to tell what a given set contains. One way is by listing the elements or the members of the set, usually between braces, that's the curly brace. So this is an example here. So we may say that set A contains 1, 2, 3, and 4 by writing A equal to 1, 2, 3, and 4. So in short, I'll say a set consists of a collection of items. In this case, it's a values. It can be characters, it can be any symbol, but they must have the same unit. So here, all these are digits, numbers. So set A consists of 1, 2, 3, and 4. Now to say that 4 is a member of a set A, we can use the symbol that look like A. So here, this symbol means belong. So we say 4 belongs A, which means A is a member of a set A, or 4 belongs to A. Similarly, we can also say that 5 is not a member of A, which we normally say 5 does not belong to A. So 5 is not a member of a set A. So by looking at set A consists of 1, 2, 3, and 4, 5 is not included. So 5 is not a member, or it doesn't belong to A. So we can also have a set B. As we can see, a set B, they are all characters, X, Y, and Z. So here we have a set A, which is 1, 2, 3, 4, and set B, X, Y, and Z. These are examples of finite or finite sets, which means there's n of it. Now, when we do not wish to list all the elements, we can use the 3 periods here. So this is called the infinity set, which means we have a lot of, let's say 1, 2, 3, 4, up to 100,000. So we just write 3 dots. So we say for an infinity set, we cannot list all the elements. So we use the 3 dots. For example, set n equal to 1, 2, 3, 4, and 3 dots, which means the list keep going, 5, 6, 7, 8. So we can see in the previous slide is finity because there's n to it. A finity set means we can list all the items and the n is 4, 1 to 4. Infinity means the list keep going, so we use 3 dots to represent it. So there's an example here. Write the following set in 2 ways. A set A of a natural numbers less than 6, which means any number before 6, less than 6. Set B of a natural numbers greater than 10, which means after 10, 11, 12 going. Or set C containing only 3. So this is our 3 examples. Let's go through them. First one, as the question said, a set A of a natural numbers less than 6. So we go from 1 to 5. So set A contains 1, 2, 3, 4, 5, less than 6. Or we may write it that set A consists of X values, and this X values should be natural numbers that is less than 6. So S is a natural number is less than 6. So either one is correct. The second one we say greater than 10. So this will make it infinity because we don't know how greater than 10 can keep going forever. So we say 11, 12, 13, 14, infinity. Or we say X is a natural number that is greater than 10. Then last one, we said the set C containing only one element, which is 3. So C contain only 3, set C. Or set C contains X, whereby X is only 3 or equal to 3. Here, set A contains X natural numbers, where the S natural numbers are less than 6. So again, it is possible for a set to contain no members, and that's what we call the null set. So this example of a null set, we have the curly brace open and close, there's nothing. And these are some of the definitions of relationship between sets. For example, we say set X and Y are equal. Set X and Y are equal if they contain the same element. So here, example, set X is 1, 2, 3, 4, and Y is 4, 3, 2, 1. They are the same. 1, 2, 3, 4, 1, 2, 3, 4. They are the same. So here we say set X is equal to set Y. The reason why, because both of them contain the same number. Now we say set A is called a subset of set B, which means everything in A should be in B. So A is a subset of B. If every element of A is an element of B, the empty set is a subset of any set. So a very good example here, we have A, set A is 1, 2, C, F, and B is 1, 2, 3, A, B, C, F. So we can see that A is a subset of B. Why? Because every element in A is also in set B. But every element in B, they are not in A. So B is not a subset of A. If A is a subset of B and B is a subset of A, that means A and B are equal set. So here we can see A is a subset of B because everything in A, all the elements in A, they are also in B. And this is the symbol we use, a subset, a C with a slash. So A is a subset of B. Now here we say if C and D have no element in common, they are called disjoint, which means all the elements in set C is different from all the elements in set D. So these two sets are disjoint. A subset means all the elements in A is inside set B, so A is a subset of B. If all the elements in A is not in B and they are different elements together, then those two sets are disjoint. So we use the Venn diagram to explain the subset. So we can see A is a subset, while everything inside B is also inside A. So B is a subset of A by looking at the Venn diagram. This is A, very large, and B is inside. Here we have a disjoint. We can see everything in M is not in N, so they are two separate disjoints. Here we have not disjoint, but we use the term intersection. Here we say S and Y are not disjoint. We will see what this means, is intersection. So those are the set operations. So here we learn what is a subset, what is a disjoint, and what is not a disjoint. In a set operation, we will call this as intersection. When two sets are not disjoint, then there's intersection there. So let's go to the set operations. So the first thing we're going to learn is the intersection. We say the shaded portion of figure 0.3 indicates where two sets overlap. The set contains the members that are common to two sets, and this is called intersection, which means where they overlap, the element in X and Y, they are the same. And that's why we say they are not disjoint also, because there's some few items here which is in X and also is in Y. Where it's not shaded, they are not the same. So we use the symbol like opposite of U, the intersection of A and B is written as A, offside U, B. Then we have a union. A union of two sets means all the elements in the set together. So intersection means I want to know what elements are common between X and Y if X and Y are intersect or not disjoint. So the elements here will prove that they are intersect or not disjoint. Union means I want everything both A and B. So A union, that's why we write here A, whereby X belongs to A or S also belongs to B or both. So we want everything. And we'll see an example soon. So here we have intersection, and here we have a union. So intersection is the element that is common in A and B. Union means everything in A and also everything in B, but we don't want no duplicate. So if there's element, let's say element 2 in A and B, we only write 2, not 2, 2. So we also have what we call the set complement. Complement means opposite. A, the complement of A is not A, or complement of yes is no. Complement of true is false. So here we can see that we say the complement of A means all the elements in A, all the element in not A is not in B. Or the best way to put it, complement A means every element that is not in A. That's the best way to say it. All the members of an items or element that are not in A is complement A. So complement A means not A. So this is an example here. Here we have intersection again of A and B. This is complement A apostrophe. We can see that it's outside A. So everything that is not in A then is A complement. That's why the Venn diagram shows shaded area is not A. U means our universal, which means all the elements possible together. If we are using characters from A to Z, values or numbers will be infinity. There's no end to a number, but there's an end to a characters or letters. So let's see the example 2 here now. Example 2 here says we have many local newspaper lists stocks of a local interest. Now, suppose that on a certain day, a prospective investor categorized 23 stocks according to weather. According to weather, one condition, their closing price on the previous day was less than $50 per share. And I said C. Their price to earnings ratio was less than 20, said P. Their dividend per share was at least $1.50, which means said D. Now, our question is, of these 23 stock, 16 belongs to set B, 12 belongs to set C, 8 belongs to set D, and 3 belongs to both sets C and D. 10 belongs to both C and P, 7 belongs to D and P, and 2 belongs to all 3 sets. And when I go to the previous slide, we can see what PCD stands for. So C means a share that is close and the price is less than $50. Or price to earning ratio is less than 20 is P. Now dividend per share was 150 is D. So now we are going to draw a Venn diagram that represents this information. And here they say we should use the diagram to answer the following. How many stocks had a closing prices of less than 50 per share or price to earning ratio of less than 20? And how many stocks had none of the characteristics of a set C, P, or D? And how many stocks had only dividends per share of at least $1.50? So here we draw the Venn diagram. Remember, we have only 3 types, PCD. So we have everything together. Now we want to do it by shading based on the condition given to us. So we shaded the 2 section. Look where the two overlap in all of them. I can see. So to assign the numbers from our data, we must begin with some information that refer to single digit. That 2 stop belongs to all the 3 steps, all the 3 sets. because based on I'm going back to the question, based on the condition they gave to us, they said, well, of these 23 stock, 2 belongs to all the 3 sets. Then 7 belongs to DMP. And we just put, we are going to put the values on the Venn diagram. So we start with the 2. Then next we have 158. 1 means belongs to what? C and D. And when we go back, we can see the condition given to us. 3 belongs to both C and D, and 2 belongs to all the sets. Now we have 5. We got 5 belongs to what? P and D. We can see that again, C is not included. When you look at 1, we have C, and also we have D, but P is not included. When you look at 8, we have P, we have C, but we don't have D. So based on the value, then the rest again, we have only 1 and D 0. So we need to have the numbers in a separate region to lie within the C union P. And that will give me 18 stock close under the $50 per share. And the price to win is 20. Now there are 5 stocks outside the 3 sets C, D, B based on the Venn diagram. And C, those stocks that had only dividend of at least $1.50 are inside the D. But outside both C and P, there are no such stocks. So we have 1. And this will be, again, the conclusion of my first lectures in Mathematics 164. And I'm going to make a record on solving some of the problems from the textbook. So again, thank you and see you in my next class.